Could there ever be a time when people travel freely among the stars? An epic journey where we leave behind the confines of our small planet and venture into the vast immensity of the cosmos. What kind of tech will let us do that? What powerful engines will push our ships to alien worlds and far-off civilizations? Today, let's dive into the cool science of space travel, from the rockets we use now to the crazy engines we might use in the future to reach even more distant stars. Ready to blast off into space? Let's go! Ever wondered how rockets manage to launch and travel through space? What makes them break free from Earth's gravity and zip off at incredible speeds? Well, it all boils down to a basic physics idea discovered ages ago by one of history's smartest geniuses, Isaac Newton. Think about this. You're on a beach, toss a ball in the air. What happens? It goes up for a bit, then gravity pulls it back down. Now imagine you're launching a rocket instead of tossing a ball. Instead of falling down, the rocket stays up and goes higher and higher. How does it pull that off? The answer is in Newton's third law of motion. Every action has an equal and opposite reaction. When a rocket takes off, it shoots out a bunch of hot gases backward, that's the action, which pushes the rocket upward, that's the reaction. This basic idea, figured out over 300 years ago, is the core of all rocket tech that's let us explore space, unlock the universe's secrets, and organize your cosmic discoveries with Notion, perfect for tracking the life cycle of stars. Notion helps you compile research, plan projects, and collaborate in one sleek platform. Whether you're mapping a star's journey from nebula to supernova or coordinating with fellow astronomers, Notion is your galactic companion. Sign up using our link to start your stellar organization journey and support our channel. Now, while rockets might seem like a modern thing, they actually go way back. Ancient China had these things called fire arrows, used in religious celebrations, like fireworks back then. They ran on gunpowder and could go pretty far for their time. But it wasn't until the 20th century that rocket tech really took off and changed everything. In 1926, an American scientist named Robert Goddard launched the first rocket powered by liquid fuel, which was a big deal for space exploration. Then, during World War II, the Germans made the famous V-2 rocket, a powerful weapon fueled by liquid that could reach heights of up to 80 kilometers. Even though these early advances were for war, they laid the groundwork for what came next. The space race between the United States and the Soviet Union during the Cold War pushed rocket technology even further. Both countries wanted to be the first to send people into space and to the moon. That's how, in 1969, Neil Armstrong became the first person to step onto the moon's surface, riding on the massive Saturn V rocket. But why is it so tough to break free from Earth's gravity? It all comes down to something called escape velocity, the minimum speed an object needs to zoom away from a planet and not fall back down. For Earth, that speed is about 40,270 kilometers per hour. Getting to that speed takes a ton of energy and fuel, which is one of the big challenges of space travel. Now picture how big and powerful rockets have to be to beat gravity and carry astronauts and their gear into space. It's like lifting a whole car, passengers and all, and flinging it up super fast. That gives you an idea of just how massive a task every rocket launch is. But luckily, we've got really smart engineers who know how to tackle this tricky physics problem. They've come up with a perfect system to make rockets work. How? Well, let's think about designing a rocket from scratch. What parts would it need? First, you'd need a tank to hold the fuel that's going to power the rocket. This fuel, usually a mix of chemicals, is what's going to give it the energy to leave Earth. Then, you'd add the engines, which burn that fuel to create the thrust that lifts the rocket up. Depending on the mission, you might have one or more engines, and maybe even extra ones called booster rockets to help with takeoff. But that's not everything. For the rocket to stay on course and steady during its journey, it needs a guidance and control system. This includes sensors, gyroscopes, and computers that keep track of where the rocket is and which way it's facing. And the outside of the rocket, called the body, has to be strong but also light, so it can handle the huge forces during launch and flight. We're talking loads that could be hundreds of times heavier than the rocket itself. When you put all these things together, you get what we call a spaceship. And each part is super important for the mission to work out. So, how does this bunch of parts actually get off Earth and into space? Well, it starts with firing up the engines. When they kick in, the fuel burns hot and fast, shooting out gases that push the rocket up. Remember Newton's third law we talked about? That's where it comes in. The force from burning fuel pushes the rocket upwards. As the rocket goes higher, the boosters eventually run out of fuel and detach from the main body. This makes the rocket lighter, so it can keep going up using its main engines. Once it's fast enough to break free from Earth's gravity, the final stage kicks in and puts it into orbit around the planet. This move, called orbital insertion, is super important for missions like going to the International Space Station or the Moon. But the rocket's journey doesn't stop there. Once it's in orbit, spacecraft have to constantly adjust their path using smaller engines called maneuvering thrusters. That's how they stay in the right spot, change course, or even travel to other places in the solar system. Oh, the wonders of orbital mechanics, don't you think? But on this journey into space, unfortunately, not everything is perfect. Space is a harsh environment for humans because, apart from microgravity, it lacks the atmosphere, radiation protection, and suitable temperatures for life. So it's not like we can just step outside the rocket and be fine. In fact, as soon as you leave Earth's atmosphere, you realize that your body enters a completely different state. Microgravity, the almost total absence of weight, starts to have unexpected effects on your body. Your bones begin to lose density at an alarming rate, and your muscles weaken rapidly. It's as if your body doesn't know how to react to this new reality. That's why we need protection. And not just any protection. During space travel, astronauts must shield themselves from these dangers using spacesuits and properly designed spacecraft. Spacesuits are crafted to provide a suitable atmosphere and shield the astronaut from the radiation and extreme cold of space. They also have life support systems that provide air, water, and food to the astronaut during the journey. Let's keep going now that everything's finally ready. Our journey to space has begun after a nerve-wracking countdown. Soon enough, we find ourselves floating alongside the International Space Station, gazing out the rocket's window at our beloved mass of water and land. What a magnificent view. But don't you feel like taking a stroll a bit further? Sounds intriguing, doesn't it? But how do rockets manage to travel through the vast and hostile environment of deep space? So far, we've understood that to lift off from Earth's surface, we need those gigantic columns of fire and smoke that propel the spacecraft into the sky. And indeed, this type of chemical propulsion, based on burning fuels, is what has allowed us to reach the Moon and establish a permanent presence in Earth's orbit. However, as we venture farther out, towards the edges of the solar system and beyond, this technology starts to pose serious limitations. Imagine wanting to travel to Mars. With traditional chemical rockets, you'd need to carry tons of fuel, making the spacecraft too heavy and costly to launch. And it's not like there's a gas station where you can refuel in the middle of the Milky Way either. So space engineers and scientists have had to think again about a solution to this problem. They've come up with more efficient propulsion systems that are better suited for the challenges of deep space. One of these advancements is ion thrusters or plasma engines. Unlike regular rockets, which burn fuel to push forward, these ion thrusters shoot out electrically charged particles to create a smoother but long-lasting push. This saves a ton of fuel and lets them travel faster. Another type of propulsion gaining traction for interplanetary missions is nuclear. Instead of burning fuel, nuclear engines use the energy from nuclear reactions to heat up a gas and shoot it out at high speeds. It's way more powerful and efficient than regular systems. Sure, for now, spaceships still use fossil fuels to get into space. But once they're up there, nuclear engines could take over and speed things up. And there are two main types of nuclear propulsion tech for this: nuclear thermal propulsion, NTP, and nuclear electric propulsion, NEP. Thermonuclear propulsion involves using a nuclear fission reactor to heat up a liquid propellant, such as hydrogen. The heat turns the liquid into a gas that expands through a nozzle to generate thrust and propel the spacecraft. One of its main advantages is that space flights would require less fuel, and NTP engines would make the journey shorter. For instance, a trip to Mars would be reduced by 25% compared to traditional chemical rockets. Moreover, a shorter time in space also reduces astronauts' exposure to cosmic radiation. On the other hand, with nuclear electric propulsion technology, thrust is produced by converting the thermal energy from a nuclear reactor into electrical energy. With this type of technology, the thrust is lower but continuous, and fuel efficiency is much higher. Speed increases, with a reduction of over 60% in transit time to Mars, compared to traditional chemical rockets. These are two alternatives that aren't actually as far off as you might think. In fact, last year, NASA gave the green light to the first phase of development for a new type of engine that uses dual nuclear thermal and electric propulsion. When everything's ready, there's a high possibility that we'll reach Mars in just 45 days, not the usual 300 days it takes. As we gear up for these big leaps, another new generation of spacecraft is ready to take humanity beyond the boundaries of our planet. One of the most promising ones is the Space Launch System, SLS, the most powerful and capable rocket NASA has ever built. SLS is the only launch vehicle that can send Orion, astronauts, and supplies to the Moon in a single mission. It's incredibly mind-blowing, but NASA isn't the only player in the space race for the future. SpaceX, led by visionary Elon Musk, is developing its own groundbreaking propulsion system, Starship. In theory, this massive and reusable spacecraft has the capability to ferry crews and cargo far beyond in space at a much lower cost than traditional systems. And although it's still in the testing phase, it's already an indispensable rocket in the current race to return humans to the Moon. Many more tests will still be needed to ensure that SpaceX's craft works flawlessly. But while these engineering wonders open up new horizons for human exploration, scientists are also exploring even bolder concepts of space propulsion. We're talking about solar sails that harness the pressure of light to propel themselves through the cosmic void, or antimatter engines that release energy in nearly infinite amounts. And if that sounds fascinating to you, wait until you hear about space-time warp engines, an idea straight out of science fiction. These hypothetical systems would harness the strange properties of quantum physics to warp space and time, allowing for travel at almost unimaginable speeds. Although still in the theoretical stage, advances in understanding gravity and dark energy could eventually make them a reality. But it's not just vehicles and propulsion systems that are evolving. Considering the new times, future space exploration is also likely to be profoundly transformed by advances in artificial intelligence and robotics. In science fiction, there are numerous examples of robots like Tars and Case in Interstellar. We don't have the ability to create robots like that yet. However, researchers are working on something similar, creating intelligent assistants that can help astronauts. One recently developed is Imon, Crew Interactive Mobile Companion, which cost $6 million and was designed and built by Airbus to be located on the International Space Station. It is a floating box about the size of a basketball and is intended to support and accompany the crew during long-duration missions, such as a trip to Mars. Ximon communicates verbally with the crew, and although it doesn't have actuators to manipulate objects, it can perform tasks like searching for items within the station or displaying instructions on its screen for repairs. The intention behind its creation is to free up crew members from some activities and give them more time to relax. Interestingly, in its first interaction with the astronauts, Ximon showed its personality as it complained about being in a specific location and not being allowed to listen to music for longer. So it'll be interesting to see how the whole thing develops afterwards. As we keep improving our technologies for space travel, we're opening up new possibilities. Soon, we'll be visiting Mars, checking out Jupiter and Saturn's moons, and maybe even reaching the farthest reaches of our solar system. But space exploration isn't just about curiosity or adventure, it's also about making sure we have a backup plan for our species' future, just in case. Elon Musk put it well. It might be a good idea to start thinking about living on other planets. And who knows, maybe along the way, we'll find out we're not alone in the universe. Finding aliens, whether they're smart or not, is a big goal in space exploration. But reaching these goals won't be easy, and it'll take a lot of money, creativity, and sticking with it for the long haul, with a vision that goes beyond one country or one generation. But if there's one thing we've shown throughout our history, it's that when we set our minds to something, we can overcome any obstacle. So there's no doubt that the future of space travel looks like a time of unprecedented advances. From the giant rockets that will take us beyond Earth's orbit, to the fantastic propulsion ideas that could revolutionize how we explore the cosmos, human imagination and ingenuity are about to take us to places we could only dream of. Can you imagine the hidden wonders we could uncover? And how many answers could we finally give to all the mysteries of the vast cosmos? Who knows, maybe in a few more decades, journeying to the stars will no longer be just a story from science fiction, but will become a reality within reach of all humanity. What's certain is that the next generation of space explorers will have tools and technologies at their disposal that we couldn't even have imagined before. The future of space is yet to be written, and you can be part of it. Are you brave enough to cross the atmospheric boundaries? Stay curious, and thank you for watching.